In problem number 1, we are going to write in standard form, which means all my degrees have to be in order. So I notice I have 2 terms to the fourth power. So that's how I got -8, because I combined those 2 terms. And then I have a squared, so there's my squared and there's my constant. Now I'm going to classify it by degree. My 4th degree is quartic. I have 3 terms, so it is a trinomial. And they want to know the end behavior. I have an even degree. Even degrees have to go in the same direction. I have an even degree and a negative coefficient with the leading coefficient. So that means I go down, down for my end behavior. In problem number 2, I first have to write this in standard form. So I'm going to go ahead and multiply my binomials. So I multiplied those out. And I can see that when I do my first term, then I'm going to have 2x to the 5th. That's my leading term. So my degree is 5, because I have 5 right here. It's my leading term. That is quintic. That's a name by degree. I'm going to, when I combine all these terms, I'm going to have 3 terms. So that is going to be a trinomial. I have an odd degree and a positive coefficient. It's going to start down and up. In problem number 3, I have to multiply these out. And I notice right away I have t plus 1 times t plus 1. So you can do FOIL, but I'm going to do the shortcut. I'm going to square the first term, t squared. Square the last term, 1. And then I go t times 1 times 2, 2t. And then I'm going to use my distributive property. I'm going to take this term, my trinomial, and I'm going to multiply everything by the binomial. I'm going to combine like terms. So I end up with a degree of 3. So that's cubic. And that would start down and up. And it's a cubic trinomial. In problem number 4, I'm going to go the other way around. I am giving the zeros. 1 is a 0. That means x minus 1 is the binomial, because 1 minus 1 is 0. And then 2, so that must be x minus 2, because 2 minus 2 is 0. And if 3/5 is 0, x minus 3/5. I'm going to multiply these out. So I'm going to do my binomials first that don't have any fractions. So I multiply x times x, x squared, and up 3x plus 2. I am going to do the distributive property again. I'm going to multiply all this out, just like I did in problem number 3, and then I'm going to combine like terms. So that's how I ended up with this. And combine all like terms. I want to get rid of this fractions. So I notice I have a common denominator of 5. I multiplied everything by 5. In problem number 5, I'm given the square root of 2 and -I. These kind of solutions only come in conjugates. So that's how I got x minus 2, x plus square root of 2. Both of them are square roots. And that's how I got -I plus I. So on the left-hand side, these are conjugates. I multiplied them. That's how I got x squared minus 2. The right-hand side, that's how I got x squared plus 1. And then I went ahead and did FOIL. So that's how I ended up with that solution. In problem number 8, they want me to find the quotient and the remainder. So I decided to do long division. You can do synthetic division. You will get exactly the same answer. So if you want to do long division, remember, first you divide. So I'm going to divide first. X cubed divided by x, that's how I got x squared. And then I'm going to multiply. X squared times x, x cubed. x squared times 2, 2x squared. I'm going to subtract that whole quantity. So I subtracted, I ended up with 5x squared. And then I am going to bring down the next number. So I brought down the next number, I began the whole process again. That's how I ended up with this answer. And notice I have a remainder of 24. So I wrote plus 24 in what I'm dividing by, x plus 2. In problem number 9, I'm going to divide. You could use synthetic division if you want, but because I didn't want to deal with any fractions, I decided to do long division. So, first thing I'm going to do is divide. 2x cubed divided by 2x is x squared. And I'm going to multiply. X squared times 2x, 2x cubed. X squared times 3, 3x squared. And then I'm going to subtract. So I'm going to go this whole quantity. So that's how I got 6x squared. And then I'm going to bring down. So I bring the next number down and repeat the process till there's nothing to bring down. Notice my remainder is 0 here, so it is a factor. In problem number 10, I'm going to list all the possible roots. So I'm going to take my last term, I'm going to call it p, which is 9. So all the factors of 9 is 1 times 9 is 9. 3 times 3 is 9. Make sure you do all the plus and minuses. And then I'm going to take them all, divide by q. Q here is 3. So 1 divided by 3 is 1/3. 3 divided by 3 is 1. It's already listed. 9 divided by 3 is 3. Already listed. On problem number 11, I take all the factors of p is plus or minus 1, because 1 times 1 is 1. And notice q is 1 here. My coefficient's 1. I divide by 1, I still get plus or minus 1. In problem number 12, I'm going to find all possible roots. So first thing I need to do is list all possible roots and then figure out which ones to use. So my p is 2, so plus or minus 1 plus or minus 2. 1 times 2 is 2. My q is 3, so I'm going to go 1 divided by 3, 1/3. 2 divided by 3 is 2/3. Now I have to use synthetic division to figure out what are my possible answers. So if I go x minus 1, because I'm picking from this list, so I go x minus 1, I get 0 for a remainder. You can use synthetic division or long division. That's how I got this cubic term. And then I'm going to continue the process again. I'm still using this list. So the next one that works is x minus 1 works again. So you can use synthetic division or you could use long division. So I tried the remainder theorem to see it's a factor first. So I plugged in f of 1 into this quotient that I got for an answer. And I got 0 again, which means 1 is an answer again. So you could do long division or synthetic division. So I divided it out. And then I got this quadratic term. Once you get the quadratic term, you can use the quadratic formula. So I use the quadratic formula here to get my answers. So my answers are 1. The other answer is 1. And then I get 6 over 6. And then I subtract it. And then I get 4/6 or 2/3. So so we start all over again. Make sure you list the possible roots and then you pick a root and try it. You're trying to get 0, then you know it's a factor. In problem 13, I want to find all the roots. My degree is 3, so I know I'm going to have 3 roots here. My possible roots. So I'm going to look at my last term. How do I get 2? 1 times 2, so it's plus or minus on both of these. I am going to use synthetic division to figure out which ones are roots. So I have to guess. If I use the remainder theorem, if I plug in 2, I get 0 for a remainder, so I know 2 is a factor. So on this problem I'm doing synthetic division. So I went ahead and did that. I brought the first number down, and then 2 times 1 gives me 2, and I added them. I got 0. So it is a factor, so I rewrote this. X minus 2, and then I have x squared plus x plus 1. This won't factor out, so I use quadratic formula, and here are my 3 roots. I have 1 real, 2 imaginary. In problem 15, we are going to use the remainder theorem. We're going to find P of A. A is negative 2/3. This is not a 0. This is a value in this polynomial. So I am going to plug into negative 2/3. I'll bring the first number down. Negative 2/3 times 6 is negative 4, and then I'm going to add them, and I continue the process. And I get 0 is my value, so I write P of negative 2/3 equals 0. It happens to be a factor, but that's not what they're asking us to do. In problem 16, they're asking us to find the value in the polynomial when A is 3. So we're going to do the remainder theorem. So I'm going to divide by 3 using synthetic division. I'll bring down the 1. 3 times 1 is 3. And then I'm going to add them. I got 6. And then I continue the process. I got 84 as my remainder. So if I plugged in P of 3 into this equation, I would get 84. In problem 18, I'm going to expand this using Pascal's theorem. So my first row is 0. This is my, and I have 1, 2, 3, 4, and I need to go one more. So I have 1s on the ends. I have 5 because I'm adding the 2 above it, and then I have 10, and then I have 10, and then I have 5, and then I have 1. Those are all my coefficients. So I have 1 here, I have 5 here, 10, 10, 5, 1. That's where I got those numbers. And notice I have the 5th power, then the 4th, 3, I go all the way down. And then when I take my other point, my z, the first one's z to the 0, then z to the first, z to the second, I count up. Each of these terms have to have a degree that adds up to 5. In problem 19, we're going to use Pascal's triangle to expand it. So I have my 0 expansion, first, second. So these are my coefficients. So my first term, 1 squared. So here I have my coefficients 1 here, and that's how I got 2, and that's how I got 1 again. If you have squared, you also could do a 2 binomials and use FOIL. That would work for that problem too.